Molar mass is probably one of the most common calculations that you'll do in chemistry. And our learning target, number 3, is this. Given the name or the chemical formula of a substance, determine the molar mass. Molar mass is the mass of 1 mole of a substance. It is the mass that contains 6.023 times 10 to the 23rd particles of that material. The molar masses of elements are found in the periodic table. If you find aluminum in the periodic table, it's number 13. Note the number 26.98 in the box with the AL. That number, 26.98, is the molar mass of aluminum. The molar mass of aluminum is 26.98 grams. And that means that if we have 26.98 grams of aluminum, we will have 6.023 times 10 to the 23rd atoms of aluminum. Whenever you have the molar mass of something, you have 6.023 times 10 to the 23rd particles of that material. Let's practice this by finding the molar mass of these elements in the periodic table. Magnesium is number 12. It's on the left side of the periodic table. And you'll notice that its molar mass is 24.31 grams. If you find krypton, number 36, on the right side of the periodic table, you'll find that its molar mass is 83.80 grams. And gold, Au, number 79 in the periodic table, in the middle, gold has a molar mass of 196.97 grams. And that means that if you have 196.97 grams of gold, you have 1 mole of gold. And you have 6.023 times 10 to the 23rd atoms of gold. You always have to be careful about the 8 diatomic molecules. Remember that when you talk about oxygen, you're talking about O2, not just O. And that means that if you want the molar mass of oxygen, what you have to do is to find oxygen in the periodic table. It's in the top right-hand corner. It has an atomic number of 8, and you'll notice that the molar mass of O is 16.00 grams, but O2 would be twice that value. So the molar mass of oxygen is 32.00 grams. Let's find the molar mass of these elements in the periodic table. Fluorine is number 9 near the upper right-hand corner, and fluorine is a diatomic element. It's F2. So what we have to do is double the molar mass of the fluorine that we see there in the periodic table, and that value is 19.00. So that means that the molar mass of fluorine is 38 0.00 grams. Sodium, number 11 in the periodic table, is on the far left-hand side. Sodium is not diatomic. Sodium is just Na. So the molar mass of sodium is 22.99 grams. If I have 22.99 grams of sodium, I have 1 mole of sodium, and there would be 6.023 times 10 to the 23rd atoms of sodium in 22.99 grams. Hydrogen. Hydrogen is a diatomic element. It's H2, not just H. So what we have to do is double the value that we see in the periodic table, which is 1.008, and we would get 2.016 grams. So the molar mass of hydrogen is 2.016 grams. If I have 2.016 grams of hydrogen, I have 1 mole of hydrogen. I have 6.023 times 10 to the 23rd molecules of H2. Now the molar mass of molecules is found by adding up the molar masses of the elements that compose them. For example, if we want to find the molar mass of H2O, what we can do is list the elements in water. There's hydrogen, of course, and oxygen. List the number of atoms of each kind. In H2O, there are 2 atoms of H and 1 atom of O. Find the values of these atoms in the periodic table. Hydrogen is 1.008. So when we multiply that by 2, we'll get 2.016. Oxygen is 16.00. That would give us 16.00 here. When we add this up, we get 18.016. But if we use our rules for significant figures, for addition, you'll notice that 16.00 has 2 places to the right of the decimal point. 2.016 has 3. Clearly 2 places to the right of the decimal point is less, so we have to round off our answer to 2 places to the right of our decimal point. So the answer would be 18.02 grams. So the molar mass of water is 18.02 grams. If you have 18.02 grams of water, you have 1 mole of water. And you would have 6.023 times 10 to the 23rd molecules of water. Let's find the molar mass of Na2SO4. Let's list the atoms. We have Na, we have S, and we have O. In Na2SO4, there are 2 Nas, there is 1 S, and there are 4 O's. If we find Na in the periodic table, it's number 11, you'll find that its molar mass is 22.99 grams. That would give us a total of 45.98 for sodium, times sulfur is 32.99 0.07, giving us a total of 32.07. Oxygen is 16.00. That gives us 64.00. So when we add these up, we get 142.02 grams. And that means that if we have 142.02 grams of Na2SO4, we have 1 mole of Na2SO4. And that means that we would have 6.023 times 10 to the 23rd molecules of Na2SO4. Let's do another. Let's find the molar mass of calcium hydroxide. Now, what makes this problem a little different is that we're going to have to figure out the formula of calcium hydroxide. Well, calcium, because of its position in the periodic table, has a +2 charge. Hydroxide is a polyatomic ion, and it has a -1 charge. If we do our little crisscross trick, we find that the formula for calcium hydroxide is Ca parentheses OH 2. So if we're going to find the molar mass of calcium hydroxide, let's list our atoms. We have calcium, we have oxygen, and we have hydrogen. We have 1 calcium, we have 2 oxygens, and we have 2 hydrogens. So if we find these atoms in the periodic table, we will notice that calcium has a mass of 40.08. Multiplied by 1, of course, gives us 40.08. Oxygen, you might remember this one already, is 16.00 times 2 would give us 32.00. This is a 3. Hydrogen is 1.008, which gives us 2.016. When we add these together, initially we get 74.096, but using our rules for significant figures, we can have only 2 places to the right of the decimal point. Because this number is a 6, we have to round this up 1, and we have 74.10 grams as the molar mass of calcium hydroxide. If we have 74.10 grams of calcium hydroxide, we have 1 mole of calcium hydroxide, and we have 6.023 times 10 to the 23rd molecules of calcium hydroxide. You can use molar masses to make equivalence statements that we talked about with regards to dimensional analysis. And from this podcast earlier on, we could say this is an equivalent statement for aluminum, this is an equivalent statement for krypton, and this is an equivalent statement for oxygen. We will be using equivalence statements like these and dimensional analysis to work out many chemistry problems. Now please go to page 17 of your packet and find the molar masses of the substances on that page.